Hello, I'm going to speak to you about the first of the 5 practices for orchestrating productive mathematics discussions, which is a book that was published through the National Council of Teachers of Mathematics by Margaret Smith and Mary Stein, and is a must-read for pre-service and in-service teachers alike. The first practice, anticipation, is a planning practice as it takes place before the lesson where the teacher predicts the different solution strategies students might use and consider the mathematical conceptions each strategy reveals. This planning practice is crucial for your confidence and classroom management. When you anticipate student responses ahead of time, you won't be caught off guard by unexpected answers or misconceptions. Instead, you'll feel prepared to respond meaningfully to whatever students might share. This advanced preparation also helps you ask better follow-up questions because you've already thought through the mathematical reasoning behind different approaches. When you're anticipating, always include at least one common misconception in your planning. Students' incorrect reasoning often reveals important mathematical ideas, and being prepared for these moments helps you turn mistakes into learning opportunities, rather than just corrections. Let us examine a problem so that we can see anticipation in action. Here we have a right triangle, and we want students to determine the area for this triangle, knowing they might not have been taught an area formula for a right triangle. The problem here shows that the legs of this triangle are of the measure 4 centimeters and 2 centimeters. During the anticipation practice, we want to think about the strategies a student might use to determine the area of this triangle and what areas would result from those strategies. So one potential strategy could be that the students might see the two measurements for the legs and simply add them to get 6. They might then also disregard the importance of units and merely write 6 or 6 centimeters. Or they might know that the area should be a squared unit. But using this strategy to get a squared unit informs you that they are missing a connection as to why area is a squared unit. A second strategy could be to confuse area with perimeter and try to continue an inferred pattern by making the hypotenuse 6, which is found by just adding 2 to 4, and then summing the 3 sides. This gives an area of 12. Additionally, the inclusion of and accuracy of units mentioned earlier applies to derivations of this strategy. A third strategy could be the application of the formula for the area of a rectangle, which is often understood to be length times height. Multiplying the legs gives an area of 8. Once again, as we have done previously, it's important to consider the units the students might write. A fourth strategy could be that the students know the formula for the area of a triangle, and then they use it accurately or inaccurately to determine their solution. An accurate application of the formula for a triangle with this particular right triangle would give 1/2 times 2 times 4, which is 4 centimeters squared. Again, we want to make sure that we consider the units the students might include or not include as potential speaking points when it's time to select and sequence during facilitation. A fifth strategy, which is quite rare but worthwhile to consider, could be that a rectangle is drawn within the triangle, formed by drawing the 2 segments that are the perpendicular bisectors of each leg. So the interior rectangle that is created here has a length of 2 centimeters and a width of 1 centimeter, because the bisectors split the legs in half. You can move one of the created triangles to be adjacent to the other, which creates a second rectangle congruent to the ones previously made. Students could then determine the area of the 2 triangles and add them. While this strategy might not be utilized by many students, from a teaching perspective, it might be good to include for students who might be very visual, and if you happen to have manipulatives, can be done physically for more tactile learners. A sixth strategy is that a rectangle can be created by drawing the sides opposite the given legs. The student would use the area of a rectangle, length times width, and then half the result to get the area for the triangle. This derives the area formula for triangles. This can also be done to demonstrate why the units are squared units. as well as give pedagogical rationale for providing the students with grid paper to work on this task instead of blank paper or line paper, where they can use this strategy and count the squares within the rectangle and then half that result to get the area of the rectangle. Though these list of potential strategies is not completely exhaustive, this kind of thorough anticipation means you'll walk into your classroom feeling confident about facilitating the discussion, knowing you have a roadmap for where the conversation might go, even when students surprise you with approaches you hadn't considered.